we have studied about gradient operation. Let us consider next very important operation called as a divergence. This is the second operation. Or second vector differentiation you need to understand. Okay. So here already we studied divergence is nothing but application of dot product. Or divergence is a dot product between del vector and any other vector. Here the combination of del dot is named as divergence. Divergence operation. Okay. So now let us consider what is the formula for divergence operation. Here you know what is the equation for del operator. Del operator is given by dou x into x cap plus dou y into a cap plus dou z into az cap. Now consider any vector. I consider that this vector is some a bar. Okay. And we are finding divergence of a bar. Fine. So now I will expand a bar also here. We have del dot and a bar is given by its x component into x cap plus its y component into a cap plus its z component into az cap. Okay, we can expand the any vector a bar in terms of its x component and its y component and also its z component. Okay, then can you tell me how do we evaluate this dot product? It is a dot product between del vector and vector a bar. Okay, so dot product between any two vectors is given by multiply similar components and add them. Okay, so first multiply x components. Multiply x components. We have dou x into x plus multiply y components dou y of ay plus multiply z components, that is dou z into az. Now we got an equation here. This is called as a divergence of a bar equation. Okay, so this is the formula for divergence of any vector. This is the formula. Okay, so here you need to understand an important point is, so we have applied divergence operation on which quantity? Here del dot a bar is a vector. So divergence operation is applicable only on vectors. Or you know that a dot product is applicable only between two vectors. So second quantity must be vector quantity. And what is this results? So these results is a vector or scalar. If you observe this one, the resultant equation do not have any direction. It do not have ax cap, it do not have ay cap, and it do not have az cap. Okay, so this entire quantity is a scalar. We say that scalar. Or simply you know that from school basics we can say that results of dot product is always a scalar. Okay, so we say finally divergence is applicable on vectors and results is a scalar quantity. Okay, now once if you understand this formula, next you need to understand what is the physical meaning of this operation divergence. Okay, so here when we apply divergence operation on any quantity, any physical quantity, what does it explains or what is it is going to find out? Okay, can you tell me what is meant by diverging? Diverging means spreading. Spreading. Or when we apply divergence operation, this divergence operation is going to find amount of divergence in the given scalar, given vector field. Okay, or when we apply divergence formula on any quantity, any physical quantity or vector quantity, it is going to find out amount of spread out. Or this divergence operation finds amount of leaving. or how much amount is leaving. Okay. So simply this divergence operation, if we apply on any physical quantity, it results gives us the how much is the amount of divergence and what is the amount of spread out and what is the amount of leaving. Okay. So this we can find out with the help of this divergence operation. Okay. Let me explain the meaning of this divergence operation with the help of some examples. Okay. So consider first example. Here I will consider an example here. First example. Let us consider any positive charge. Any positive charge. What is the direction of electric field due to positive charge? Always electric field moves away from the positive charge. Moves away from the positive charge like this. Direction is outwards. Now let us consider, I represent this entire electric field with a mathematical equation E1 bar. Or we can say E1 bar is electric field due to positive charge. Okay. Then let us find out what is the divergence of E1 bar. I said that what does divergence finds? Divergence find amount of diverging or amount of spread out or amount of leaving. Okay. So I am finding amount of divergence in the vector field E1 bar. So just see this vector field diagram. E1 bar field diagram is shown here. Okay. By observing this field, can you tell me, is the field is diverging or not? Yes, the field is diverging from the source or charge, or field is leaving, or field is diverging, or field is spreading. Field is spreading from the source point. Okay. So whenever field is spreading, what happens for amount of spread out in E1 bar? Definitely non-zero. Okay. So simply we can observe that whenever divergence of any vector field is non-zero, then the field is called as a diverging field. Our field is called as a source field. Okay. So, and another important thing is that when it is positive value, if divergence of any vector field is non-zero and also it is a positive, then the vector field E1 bar is called source field. Source field. Or it is called as positively diverging field. Positively diverging field. Positively diverging field. Okay. Similarly, let us say another example. Okay. So in the next example, let us consider negative charge. What is the electric field due to negative charge? Then we find what is its divergence. Let us consider another example here. Example 2. Consider a negative charge. And what is the direction of electric field due to negative charge? We know that electric field ends at the negative charge. Total electric field will travel towards the negative charge. And I consider electric field due to this negative charge is E2 bar. Now let us find out what is the divergence of E2 bar. Here divergence of E2 bar is 0 or non-zero. That's what we need to find here. Okay. So in the previous example, we have studied about positive charge. Now it is negative charge. What is the difference between previous diagram and this diagram? So both the diagrams look same. Only difference is direction is opposite. For positive charge, flux is moving away from the charge. For negative charge, flux is moving towards the charge. Only direction is change. Okay. Here also, in this case also, field is spreading, but the field is negatively spreading. Or this field is called as a sinking field. Sinking field. Total entire field is sinking at the negative charge. Okay. Or which is called as a negatively diverging. Diverging means spreading. Negatively diverging means sinking. Okay. So this field will have divergence non-zero, but answer is negative. Okay. So this is called as a negatively diverging field or a sink field or faucet. Okay. Whenever divergence of any vector field is non-zero and negative, then the field is called negatively diverging field. Negatively diverging field or sinc field or faucet. That is called as a faucet. Okay. So it's an example of a negatively diverging field. Now let us consider third example. Example 3. So here for this third example, let us consider a field as shown in the diagram. And this is also an electric field. Let us represent this electric field with E3 bar. The electric field E3 bar is shown in the diagram. Now let us find what is the divergence of E3 bar. What is the divergence of E3 bar? Okay. So now here, whenever we want to represent a field, we represent any field in terms of arrow. Okay. Here, length of the arrow indicates magnitude of this vector, and head of the arrow indicates direction of this vector. Okay. So now if you see, observe this diagram. In this diagram, I have shown you same length of arrows. All the arrow lengths are same. That means magnitude of this E3 bar at every point is same. Our magnitude is constant. Its magnitude is constant. Okay. And also observe what is the direction of all the arrows. All the arrows are showing right side direction. That means at every point field direction is right side or field direction is constant. Okay. So the direction of the field is also constant. Okay. So completely we can say that the field E3 bar is a constant. It has a constant magnitude and constant direction. Okay. Or we can say field at every point is same for the diagram shown. Such a field is called as uniform field. Uniform field. Because field direction at every point is same and field magnitude at every point is also same. It is called as uniform. Okay. Now let us apply divergence operation on this E3 bar. Okay. Where E3 bar is a constant having constant magnitude and direction. So it is a constant. And this divergence operation is a differentiation or it is a spatial differentiation. What is the differentiation on any constant? 0. Okay. So the meaning of this one is that this field shown in the diagram is not diverging. There is no divergence for this field. Okay. So that means it is not spreading. It is a constant everywhere or it is the same everywhere or it is not changing at any point. Okay. So whenever divergence of any vector field is 0, then the vector field is called divergenceless. Divergenceless field or it is called solenoidal field. Solenoidal field or it is called no source and no sink field. You know that source field means divergence is positive. Sink field means divergence is negative. What about here? Here divergence is not 0 and it is not positive, it is not negative. It is exactly equal to 0. So it is also called as no source, no sink field. Okay. Simply whenever divergence of any vector field is 0, then the field is called as divergenceless or solenoidal or no source and no sink field. Okay. These are the examples of divergence. Consider a problem on divergence. So just we have studied about divergence operation. So we know what is meant by solenoidal field. So if divergence of any vector field is 0, then the vector field is called as a solenoidal field. Okay. So let us consider a problem on this one. Consider a vector field A bar is given by 3y square z minus 4x into ax cap plus 9x square z minus 6ky into ay cap plus 11x square y plus 2z into az cap is a vector field. It is represented with a bar. Now, if a bar is solenoidal, a bar is solenoidal field, then what is the value of k? What is the value of k? So, here it is given that a bar is a solenoidal field. So, for solenoidal field, the divergence of the vector field must be equal to 0. Okay. So, we are going to consider that a bar is a solenoidal, hence it should satisfy the property divergence of a bar is equal to 0. Okay. So, now what is the formula for divergence of a bar is, so we have dou by dou x of x component of a bar ax plus dou by dou of y component of a bar, that is ay, plus dou by dou z of z component of a bar az. So, this is the divergence of a bar which is equal to 0. Now, let us identify what are the components, different components in a bar. Okay. So, just in the given a bar, the total term multiplied with ax cap is called x component ax. And next, this second term multiplied with ay cap is y component of a bar ay. And this is the third term which is multiplied with az cap is called z component of a bar az. Let us substitute this one in this formula. Okay. So, here the equation becomes dou by dou x, ax or x component of a bar is given by 3y square z minus 4x plus dou by dou y of the y component of a bar is given by 9x square z minus 6ky plus dou by dou z of the z component of a bar is given by 11x square y plus 2z, which is equal to 0. Here if you observe, all the differentiations are partial differentiations in this equation. So, we say that dou by dou x differentiates only x terms and dou by dou y differentiates only y terms and dou by dou z differentiates only z terms. Okay. Hence, the differentiation will be equal to minus 4 from the first term, minus 6k from the second term, plus 2 from the third term, which is equal to 0. Okay. So, then it will be minus 6k minus 2 is equal to 0, or this implies k is equal to minus 2 by 6 or minus 1 by 3. Okay. So, finally, we say that the answer k is equal to minus 1 by 3 when a bar is a solenoidal field.